Hi, student. Myself, Dr. Dharampal Singh, Associate Professor and HOD of the Department of Computer Science and Engineering, JIS College of Engineering. Your paper name is Formal Language and Automata Theory, and paper code is CS403. As you know, that prerequisite of this part is the digital logic, computer organization, and the computer fundamentals, and the course outcomes. As you know that after completion of the course, we can get the machine with and without output. Already we know that we have covered the module 1. We can also get the idea about the different languages, what is the perceived the power and limitation of computer, and take decision on compatibility. So these are the things present in course outcomes, and I assure that after completion we are aware about all the things. And this is a COPO mapping of your course with the course outcomes with the program outcomes. Now these are the your course contents. Now today lecture is the compatibility graph. So in the previous class, I have discussed the merger graph. So here we are going to learn about the compatibility graph. Okay. So when you are aware, we have designed the merger graph based on the table, and we have used the concept of merger graph when the machine are incompletely specified, means next state and output is not given there, and we require to minimize it. So we can use the concept of the merger graph. So already if you see the previous lecture, then you are aware about that merger graph. Okay. So this phase we can see that this machine is also incomplete because I can say I0, I2, sorry, I1, I2, I3 and I4. If you give the input here, these are the incomplete, no state, no output. Here no state, no output. So they are the incomplete specified machine there. Okay. So as you know that when you go for the design of the merger graph, whatever the states are there, we can draw the vertex for that. Okay, so you can see that here 5 states are there, 5 vertex we have drawn. Now you have to check the compatibility between A or B, because in the previous class I already explained that what is the meaning of compatibility graph, sorry, what is the meaning of compatibility pairs and what is the meaning of implied pair. Okay, so here I can see whether they are compatible or not, we can check. C comma 0, here I can say no output and state, so I can say they are compatible. Here this is similar case, but here I can see that here output is 1, output is 0, so they are not compatible. So A and B are not compatible, so that is the reason you can see there is no age between A and B there. Now compare A or C dash C comma 0, D comma 1 dash, E comma 1 dash, A comma. So they are compatible, but there is no implied pair. So undirected, unbroken edge we can draw here. You can see this one. Now similarly, you have to go for A or D. If you go for the A or D, we can check. Again, there will be the here 1. Here you can say no output is yet, so I can assume it is correct. Means it may be the 1, it may be the 0. It is the when dash is there, don't worry about it. You can say they are compatible. So here compatible, okay, and here. But here I can get the implied pair like B and E if I go for the A and E. So that is in B and E written. Okay. Similarly, if you go for the A or E, so here I can say this is okay. This one is also okay. This one again same thing. It may be 1 or 0, so we can say these are the compatible. And what is the implied here? C and E written. Why it is unbroken? Already know that I have explained. I am going to explain this part also. So this is the A is over. Similarly, for B, we have to draw the different edges. After that, I can get the these are the pairs of the implied pair of the different edges there. Okay. Now you have to check whether C and E are the any edge between C and E exist. We can see here it is exists there, but it is cross here. So I can start from the A or B. Any age from A or B exists here. First you can check. There is no age between A and B. So as you know that in previous lecture I mentioned that if these pairs are not compatible, so if any implied pair in the ages of two vertex, I can cross this one. Even B and C are compatible, but A and B are not compatible, we have to cross this one. If I cross this one, so C and E become the incompatible. You have to check C and E exist here. I can see here exists. So I can make this one is cross. If I cross this one, then A and E become the incompatible. So we can see that A and E exist any places. This places AE, not AE. But here I can see A and E there. So I can cross this one. After that, you have to check B or D exist in any places. If it is, I can also cross that edge. But here I can say BC, BE, DE, but BDE not exist in any places. So I can stop. So when you stop here, so what are the compatible pair I can get here? So when you see that, here we are going for the compatibility graph. This merger graph, here we can see that by using that, I can say these are the compatible pair, or you can say minimized pairs are there. Okay. So here what we are going to learn, here we can say that we have draw the compatibility graph between the pair of edges. So what is the compatibility graph is? If you read here, the compatibility graph is the directed graph. If you keep in mind that merger graph is the undirected graph, but compatibility graph is the directed graph whose vertex corresponding to all compatible pairs and for which an arc label from vertex Si, Sj to vertex Sp and Sq if and only if Si, Sj implies Sp and Sq. What is the meaning of this one? The first one we can go for we have to draw the vertices corresponding to all compatible pairs. So in this figure, what are the compatible pair we are getting? We are getting AC, we are getting BD, so BC. This is already crossed, so we are not getting this one. We are also getting the B and E. You can check that. AC retain, BC retain, BC where BC retain, BE sorry BE retain. You can see here. Now the after B over, we can go for C. CD is there. Okay, so CD we can write this part CD. After that, we can say D and E. You can getting D and E are compatible also. You have to write the D and E. And at the end, we can get the A or D here. Okay, these are also compatible here. So all the pair we have to write. So first task we have done. What are the vertices? Means all compatible pair like AC, AD, BC, DE, CD, and the B we have written that. Okay, that after that it is saying the second line. An arc leads from vertex Si to Sj. Means from this to this. When I send the vertex, if and only if I suppose if I consider this is the Si and this is the Sj and this is the Sp and this is the Sq. Okay. So it is saying that you have to draw the direct edge from Si to Sj to the vertex Sp and Sq if and only if Si Sj implied the Sp and Sq. So when you see the figure here, what we have done, we have drawn the AD to BE. Okay. So I can say that from this figure, BE is the implied of the AD. So that is reason we have drawn the direct edge from AD to B. You can check from this merger graph. Yes, A or B is the my edge. This one. And implied by this one is the Sp and Sq means BE. BE we can check here. So that is the reason we have performed the direct edge between the AD to the BE there. Now from this figure I can, without seeing the merger graph, you can say that I can draw the direct edge from BE to BC. So there is must be BC is implied by the BE. You can check it. BC is implied by the BE. So you have to draw the direct edge from the. Here DE to BC is edge means I can there must be BC is implied by the DE. You can check it. BC is must be implied by the D and E there. So that is it. Okay, so this is the way. So this is the way we have to draw the edges between the all the pair, and this graph is known as the your compatibility graph. Compatibility graph of the your incomplete specified machine there. Okay. So why they have drawn the this dashed line there? This dashed line is saying that the certain logic is present here. Logic is that it is saying that we have to consider the compatibility graph, and this is the minimum cover. Minimum cover of the compatibility graph is that here we have to, if I take all the edges where all outgoing edges of this one present in this graph there, all outgoing, you can see outgoing of this one AD is present in this graph. If I say dash line here, outgoing is B, it is present, outgoing of this is present here. So all outgoing is present and all incoming edges is also present here. You can see what is the incoming edges. Outgoing of this is, so it is present B in this graph. Outgoing of this is ABC, it is present in this graph. Outgoing of AD, it is also present in the this graph. Or incoming edge is also present. You can see incoming, 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 all the incomings are present. So here I can say that this is the minimum cover of the your given. Means if I go for the minimization, I can say AD, BC, and B is the minimum cover of the given machine which is present in this figure. In this way, we can minimize. Okay. So I hope that this one clear your idea regarding the compatibility graph and minimum covering of the graph. So thank you everyone.